Hi, my name's Samy Kamkar. I'm a security researcher, computer hacker, and co-founder of Openpath Security. I've been challenged today to explain one simple concept in 5 levels of increasing complexity. My topic? Hacking. Hacking to me is using or manipulating a system in a way that it wasn't intended or really expected. And that could be a computer, or it could be a phone, or a drone, or a satellite. It could really be anything. Do you know what computer hacking is?
It's bad. Like going into someone's personal account, changing some stuff, or just stealing some information or your money.
Yeah, it's crazy. There are really a lot of bad or malicious hackers out there who are doing just that. They're going into people's accounts and they're stealing money. But there's also another side of computer hacking where there are people who are trying to learn how those bad hackers are actually breaking in to the bank accounts.
Did they return the money, give them their money or something like that?
What they're trying to do is they're trying to even prevent the bad hackers from getting in the first place.
So they put a protection account or something?
Yeah, exactly. They're looking for ways that they can create protection. It's kind of like the lock on your front door. That lock is to essentially prevent bad people from coming in or people accidentally coming in when they shouldn't. A hacker is essentially looking at a way, how can I get into this lock? But then there are the good ones who are trying to unlock it so that they can tell the company that made the lock, hey, we can actually protect people by making the lock a little harder.
What would they do about the people in the broken lock?
In many cases, they'll send them a new lock. So it's an upgraded, a better version. Sometimes that's new features, but sometimes that's bug fixes and ways to protect you as well.
But they may get arrested because they might get mistaken.
That's a very good point. You should definitely make sure that you're obeying the law. They might work with the lock company and say, I'm trying to improve your product, and they're trying to find these holes or problems and then share that with the company. Even though the good hacker is doing exactly the same thing as the bad hacker, it's the same exact skill set, and you're using the same exact techniques and information to try to break that lock. But your goal as a good hacker is really to help everyone like you and me to make sure that our stuff is protected. So hopefully they don't get in trouble because they're the good guys.
When did you start doing the good hacking?
I started doing the good hacking when I turned 9 years old.
Wow.
I started going on the computer and playing video games, but I had some ideas of my own. And that's where I started to learn how to hack. I wanted to play with my friends on this video game and just change the way that things looked.
But that'd be kind of bad because maybe the creator did it for a reason.
That's entirely possible. They may have done it for a reason, but you may have come up with a really good idea that, do you think there are other people who might like the idea that you came up with?
Yeah.
When you have creative ideas like that, hacking can actually allow you to change the way a system works. And that means you can change a game and how the game is played. And then you can share that with your friends and other people who like that game. Once I started learning how to do it, I found that things that were harder for me, I could make easier.
Did your parents approve of it?
I don't think my parents knew. But when my parents found out that I was doing it for good, I think they were happy. Do you do anything with computers or any coding?
I like to play coding games, and I like to go on code.org, and they have a variety of games for different ages. So I really like to do that. For example, the game Flappy Bird, it's puzzle pieces. So they would tell you to connect something, and then you would play the game, and then you could see what you connected.
Interesting. So it's like a graphical interface where you can connect different pieces together, kind of wire them together.
Yeah.
Oh, that's pretty cool. What do you know about computer hacking?
I don't really know much about computer hacking, actually.
So on code.org, one of the things you've been doing is actually building a game, or that they have a game and then you can actually rewire some of the inputs and outputs of that. Is that right?
Yeah.
Okay. With computer hacking, it's actually the same thing. Really, you have some sort of system and you have a bunch of inputs and you have some sort of output. And actually, you as the designer, you're essentially designing games and software. You're saying, well, I will only allow a user to really control these inputs. Can you think of any inputs the computer might have?
Spacebar?
Yep. There's also things like your mouse. And there's even things like the microphone itself is actually an input device. It's taking something from you, which is the sound, and it's then transmitting that, and it's actually sending it to me. Are there any other things that you can talk to a computer, you can give it information?
Camera?
That's absolutely another input that exists on your computer. That's how I try to think of things, is there's just a bunch of inputs. Often, if you're trying to break something or hack something, you're really saying, okay, how can I control these inputs in a way that wasn't necessarily expected?
What inputs would you normally use to hack?
Typically, it's going to be something like the keyboard, right? I'm just going to be typing keystrokes to be talking to some piece of software or hardware. But other times, it can be other things, like even the temperature of a computer can actually affect how the computer operates. And it might be advantageous to me to cool down the computer and actually slow down the movement of electrons in something like memory, so that if a computer shuts off, it stores something that was in memory, like a password, and stores it for longer, enough time that I might be able to actually extract it through some other method.
How long does it take to get in?
It just depends what you're trying to do. In some cases, it could literally be seconds because you already know how the system works. In other times, it could be years. So what have you learned about hacking?
I think hacking is actually really interesting. There's different languages to hack in. I've also learned that a lot of things could be hacked that you don't necessarily think that could be hacked.
Have you started studying cybersecurity?
I started this year. I took my first course, so haven't gone too deep into it, but we got a basic idea of basics of information and network security. We learned about how networks are set up, like the different types of topologies like star and mesh, and also how networks are designed with different levels of security.
Have you heard of the breach of Target, where they were breached many years ago and their point of sale systems were hacked?
Yes, I heard about that.
So where people are swiping credit cards, those credit card numbers were stolen. They hired a company to come in and perform a penetration test to see, can the good guys essentially break in again to prevent this sort of thing in the future? And when this team came in, they found they actually were able to get pretty much to the same point of sale system. And the way they did that was by exploiting an internet-connected deli meat scale. Once the company was able to essentially get into the deli scale, because the deli scale was on the internal network, then they were able to really escalate privilege and find a vulnerability within another system. Essentially, that just got them into the network. And once you're in the network, it's often really easy to then escalate from there.
I've heard about similar attacks in hospitals using hospital equipment, but I'm surprised that something as simple as a meat scale would have been used in such an attack. We discussed it in class as how hackers look at some of the weakest links in these large networks and use those to tap into networks.
Yeah, that's another interesting concept. It's really just different layers that we have for protection. Because often when you're talking about something like a corporate network or even your home network, you typically have sort of one level of the defense, right? If someone can break that or can get in through some other system that is connected or exposes some other protocol like Bluetooth, right? You can connect to a Bluetooth device without being on the wireless network or without being on the LAN. That potentially gives you another place that you can pivot and then access other devices. Because if something has both Bluetooth and also Wi-Fi, well, if you can get in through Bluetooth, then you can then access the Wi-Fi and get to other devices on the network. Are you familiar with buffer overflows?
No, I'm not familiar with that.
If we were to write a program that asked for your name and you typed in your name, but before you could type in your name in a low-level language like C or C++, you'd have to allocate some memory. So you might allocate a buffer of 100 bytes, because whose name is going to be longer than 100 bytes or 100 characters? But what happens if you were to not really check that they limited to 100 bytes? Do you know what happens if they essentially start typing over that 100 bytes?
In that case, it would be an error for accessing invalid memory.
Absolutely. You'd essentially cause like a segmentation fault.
Yeah.
But what's really cool about that is when you're going into memory, you're starting to cross over that boundary of that 100 byte allocation, and now you're starting to write over additional memory. That other memory is really important stuff. So you have your name, the 100 bytes there, and then right next to your name is the return address. And that's the address that the code is going to return to after that function is done, and it's going to jump to that address. But after you type your 100 bytes, the next few bytes that you type, you're actually going to overwrite that return address. So that return address could essentially be another address in memory. So what you end up doing is you type a name, and it's not really a name, it's really just code. And that code, you keep typing until you get to the return address, and you start typing an address, which is really the beginning of your name. And your computer, your processor is actually going to read that address, and it will jump back to the beginning and then execute that payload. So that was sort of the very first thing that I think was super exciting to me when I started learning about really reverse engineering.
So how does the buffer overloading relate to what you are doing in terms of network security or designing software for penetration testing?
Ever since buffer overflow started many years ago, there have been a lot of protection mechanisms built to make it difficult to exploit. More and more, we're actually using smaller and smaller computers with small amounts of compute power. If you take a car, you have hundreds of microcontrollers that are all running there. So they don't really have a sophisticated operating system that can try to prevent attacks like buffer overflows. So how do we keep these low-cost computers in here while adding layers of protection to prevent malice and these types of attacks? Sometimes it actually is, how can we write software or how can we build a system that prevents these types of attacks from entering? But oftentimes it's really looking for how can we find new attacks that we haven't even necessarily thought of. What got you interested in computer science and information security?
I got interested in cybersecurity because I'm really into global affairs, global politics, and you often hear in the news about the rising power of China, the rising power of Iran. I enjoy how interdisciplinary computer science is. Like nowadays, there's so much going on in the world of computers, and that's what fascinated me.
You brought up China and Iran, and something that's interesting about those areas is really censorship, right? They have essentially censored internet. In the US, we have a really interesting internal struggle here where we actually have government agencies like the State Department that are funding software to evade censorship like Tor and other mechanisms. While then we also have an internal struggle where we have other organizations like the NSA who are specifically looking to break that exact same system that the US government is also funding.
There are a lot of like ethical questions about whether we should be intervening in other countries, but it's pretty interesting that two different agencies of the government are actually working on contrasting technology. I can actually understand that because if we are creating a technology that we're going to deploy somewhere else, we should know its limitations. We should know how to control it.
It's good for us to understand like how these systems can really break down. Although I think one thing that I see is that some of, let's say, the organizations that are looking to break this are not necessarily going to share once they actually learn that information. They might actually sort of hold that in their back pocket and use it when it's advantageous to them. What kind of projects are you working on?
This is the end of my first year. I'm a PhD student at NYU Tandon School of Engineering. I'm studying security systems and operating systems. So security for operating systems. I've been mostly working on a project that limits executables exposure to bugs in the kernel. It's run by Professor Justin Kapos there. He found that the majority of bugs that occur in the Linux kernel happen when you're doing things that people don't do that often, that programs don't do that often. So I'm designing like a runtime environment that lets you limit what a certain program has access to, but also the things that it does have access to is also limited to those popular paths in the kernel. So it can't access areas that aren't under more scrutiny.
So essentially, it's a really potentially a stripped down operating system, or I guess it's a virtual machine.
Basically, we're creating a user space operating system.
Have you done any work in side channel analysis?
Like a little bit. I've read the Rowhammer paper. I find it really interesting, but it's nothing that I've actually worked with.
So the side channel analysis is really looking not at vulnerability within a system, but really unintended consequences of what the system is built on. A very simple example of maybe of a side channel is putting your ear to the ground to hear if there are horses coming towards you. And the same thing applies to technology. So you can have something like a CPU. It's executing instructions. Certain instructions use a little bit more power, and power is reserved in these capacitors, which are like tiny batteries next to your CPU. And as they're pulling power, there's something in physics called the electrorestrictive effect, where the capacitor will move in a very, very tiny amount. And then, although we can't hear it, the microphone on a mobile device can actually listen to that. If you then listen to that and you say, oh, I see a pattern here, and you can go all the way down and then reveal the full password, the full key, even though it can be argued that the algorithm itself, there's no problem with it.
So all memory devices are it's just a bunch of gates, and they're in rows. They basically all hold different pieces of memory. That's all the gates are. Either they're turned on or they're turned off. So what Rowhammer found is it tested a bunch of different memory devices and found that by doing a certain order of storing things and then pulling that information back in a certain way in one place, would actually flip gates in a different place. So that you could actually do a bunch of things to a piece of memory that had nothing to do with something that may be critical in a different place and actually change its contents. And that obviously exposes all sorts of security issues, because that's very hard to predict.
Yeah, I suppose the physical adjacency, right, of the underlying transistors and capacitors that are holding that storage. That's crazy. I think the first time I heard of an interesting attack like that was learning about the cold boot attack. Being able to, someone enters their password on their computer and that decrypts their hard drive, and then they walk away. Being able to extract that password is really difficult. If I can pull that memory chip out and extract that memory, put it in my own device, except the problem is memory is volatile, so it'll erase as soon as I pull it out. You can take something like that canned air, turn it upside down, cool that computer, make it real nice and cool. Then you have a minute or two to pull out the memory, put it in your own device, extract the memory, and then you're good. Such a simple method to really extract something kind of critical. Like Rowhammer, it's such a low level vulnerability, and it's, you could argue that it's not necessarily a vulnerability in the architecture itself, but rather exploitation of physics at that point.
I've spent a decent amount of time with this stuff, and in my mind, a lot of that is a nightmare. Over the last year, while I was doing some of the other stuff, I actually designed some microcontroller boards for a company that was doing stuff with like a smart watering project. The problems with like updating is just like, that scares me the most. Like, people don't update their own stuff, let alone these like devices.
I keep forgetting to update my fridge.
I find myself like trying to shy away from owning like smart things.
That's pretty challenging if you want to use wireless, right? If you want to use a wireless router.
Yeah, I mean, there's obviously essentials. But, no matter what, you can't really avoid any of this.
The risk right now, just during this quarantine, is actually massive now that we think about it, because you might have these legacy systems, they were built 20, 30 years ago, and it's too costly to upgrade. But now you can't actually have a lot of people in a single location. So potentially they actually do have to now add some sort of remote capabilities to these systems that were never meant to be on the internet. Have you ever had any ethical concerns with the stuff you're interested in or the work you do?
Oh, yeah, for sure. When people find vulnerabilities, I think it's their duty to release those to the public.
Especially now that we're seeing more and more companies who are trying to make it illegal for you to inspect the vehicle that you've purchased, right? Something that you actually own.
Yeah, I think that's nuts. I'm firmly against that, for sure.
What if it were illegal? Would you then do it? Fortunately, it's not today, right? It hasn't been, despite their attempts, none of that has been passed. But if you had a vehicle and you wanted to inspect it, but all of a sudden it passed,
I don't know. Probably, yeah. No, I don't think that's hurting anyone.
But the laws don't always equate to hurting anyone. I ethically think similar to you in that, what is moral to me is as long as I'm not intentionally hurting others, right? Yeah,
I think we see every day that ethics and the laws aren't necessarily the same thing all the time.
Hey, Colin. We already know each other, but why don't you introduce yourself for the people watching?
Hi, I'm Colin O'Flynn. I live in Halifax, Nova Scotia, Canada. I do hardware hacking, both in academia at Dalhousie University and in industry at my startup, New AE Technology.
What have you been up to, and what are you working on?
Lately, I've been doing, always a little bit of side channel analysis. So what I really do, is all hardware layer. So I've been looking, at some various devices lately, at how susceptible they are to fault attacks, what that sort of means in real life, not just purely the research side, but also how much should you care about it.
Maybe a mutual acquaintance of ours, Jasper, gave an example of fault injection, and I like to use that as what is like when I'm trying to explain fault injection. He shows a pinball machine, and the pinball machine, obviously the two inputs are the two plungers when you're playing a pinball machine. But fault injection, you can tilt the entire pinball machine, right? You're just introducing some external variable that's outside of the traditional inputs that you're used to, and you've now controlled the environment in an advantageous way to the user or the player. Can you give an example of some type of fault injection that you're doing or working on?
One of them was looking at like a little hardware Bitcoin wallet, and you could use fault injection to actually recover secrets from it. And a lot of devices, the whole idea is pretty cool, right? Because you tell the device, hey, I want to authenticate, and it's supposed to run some really crazy math that authenticates it, but instead of doing that crazy math and attacking the math, you just attack the check at the end.
We're also scratching the surface of like what is possible. It's not necessarily just the system itself and not necessarily that algorithm itself. Like you said, you don't necessarily need to attack the math. In some cases, you can just attack that check. And I think something that's been pretty cool is looking at higher energy particles. It's going to be maybe hard to entirely confirm, but I think it'd be really, really cool to actually see. Like, I want to see one of these faults because I haven't seen it myself. And also, how do you know that you've seen it? I've started playing with setting up a cloud chamber. The cloud chamber lets you actually view high energy particles going through, sort of like in a small jar with some evaporated alcohol. And I thought it'd be really cool if we put some memory chip in there, like a basic memory chip, and we just fill it with some data. But then you put a camera on that area and you just watch. Assuming that there is a high energy particle that actually hits that memory, that should potentially flip the energy state of that bit. The outside microcontroller should be able to read that and actually say, oh wait, the data changed, even though I'm not changing data, I'm only reading data, and we should be able to visibly or optically see it. What I'm wondering is, could that be a next area of research? Because I don't think anyone's actually looking at intentionally injecting high energy particles to take over a computer, when really that's another technique for fault injection, technically speaking.
This was actually tied into something recently I was looking at, which was, flipping flash and EEPROM memory.
You mean flipping bits within flash?
Yeah, exactly, right. So flipping it in this stored flash memory. And so someone's done it with x-rays. There's actually, I forget who now, there's a paper, at least one. And it's just like a little plate, right, they make with like a hole in it to concentrate the x-ray source, and it works. Yeah, it's super interesting. Like, one bit in memory means a lot, especially the flash memory side. Yeah, visualizing it would be cool, though.
I've never seen maybe call it a verifiable visualization of it, right? We know it's true. You can get skin cancer by going outside and having too many high energy particles hit you, but we've never seen it. And we know it can happen to a computer chip, but I've never seen both.
Yeah, so it's funny you mentioned making it more obvious for staying on fault injection right now. This is lately what I've been up to a lot of, making a little kind of, like electronics kits of old, right? And you can assemble it all yourself and see how it works. So making something like that for fault injection. So all kind of older logic and stuff like that. So, it's sort of based on, like you had presented, the little MUX chip, voltage glitcher. That sort of idea, using just discrete logic to generate the actual glitch itself. So, but, it's part of, I think, this stuff, right? It's like people don't know about it sometimes. Like, even engineers designing systems, it's new to a lot of people.
The thing is, even if you know about that, then there's so many other areas that someone won't necessarily know about, because there's so many, I guess, potential areas for a fault to occur. Where do you think security is going, or new research is going? Are any new areas you think are coming out or going to be more interesting, pretty soon?
Fault injection, I think, has become pretty interesting. Like, there's been a lot of people poking at that, and I think a lot more products of interest. Side channels still might have a bit of a comeback. Basically, what I kind of see is a lot of the really cool stuff has been in academia, because product security hasn't kept up, right? For the longest time, doing these attacks on hardware was pretty straightforward. You didn't need these crazy attacks. It looks like a lot of devices are coming out now that actually have real claims to security, right? More than just a data sheet mention. Like, there's actually something behind it.
For me, I think the things that have been recent and super interesting are typically down to physics levels effects that maybe we haven't seen before. I think my mind was blown with there was the light commands research, and they were able to modulate sound, although it's purely over light, using a laser. They would hit the MEMS microphone, and it was picking that up and was able to then interpret it and essentially take control over light.
I'm curious of the backstory to how they found that. Because if you told me that, right, you said like, hey, Colin, you should test this out, I probably would be like, it probably won't even work, right? Which is like a lot of side channels. When I first heard about it, working, doing firmware stuff, it was like, that sounds like it's not going to work. Like, that sounds impossible. The whole area of hardware hacking, it feels kind of like cheating, because, as you said, someone designing the system needs to know about so many different ways, right? So there's so many ways to break the system, and if you're designing them, you need to know all of them. But when you're attacking it, you really need to know one, right? So I can know nothing about how does ECC actually work. I have some vague hand waving I can tell you about. But if you gave me a pen and said, okay, write it down, specifically the equations and what they mean and how the point mall works and stuff, right? No idea. But designers are like the other side. It's almost like I don't want to say lazy side of it.
It's the easier side. I would say my side is the easier side, right? I'm on the offensive side. I want to break into things. Someone on the defense side, they might have a system was developed and they now need to patch 100 holes. They patch 99 of them. I only need to find out one.
Yeah, there's no downsides is what you're saying.
Yeah, only when you get caught. I hope you learned something about hacking. Maybe next time a system behaves in a way that you weren't expecting, you might just be curious enough to try to understand why. Thanks for watching.